Hello, this is Dr. Joe Connor, the Connor Bubble. Welcome. We want to invite you in. We have some very interesting bits of information about engineering. Don't turn off the set yet, say it doesn't involve you, but you're going to find out there's some excitement out there about engineering, and we want to get you in the scoop, in the know, in the beginning of what can happen and what are the possibilities for your children, for yourself, and also maybe that career change that you're looking for. Some of the things we're going to be talking about might be of interest to you. We have a very special guest from National Instruments, Ingo. I won't butcher your last name. I think it's
Foldvari.
Foldvari. And he is the exact academic program manager for California. And we're going to be talking about, if you have a view of the table here, we're going to talk about some things that are going on in the area of engineering, and we're really excited. Ingo, thank you for joining me.
Joe,
this is the first time that we physically have met. We've talked on the phone, exchanged a lot of emails. It's like I've known you a long time.
Yeah, it's for over a year now.
Oh, yeah. And so what we want to do is we're excited about engineering. My background is in biochemistry, but I see the potential of engineering because I'm on the advisory board of a program at the University of Southern California called CDEBI for short, the Center for Dark Energy Biosphere Investigation. They're looking at the deep ocean and seeing what's down there, and a lot of things have to involve engineering and items that can go down and research and look at the ocean where a human being can't go down there, obviously, and the engineering plays an important role. And Ingo is going to tell us what can be done to help young people get in the swing of things in terms of engineering. Let me ask you a question before, because we have a lot of videos. Is there much interest in young people in this kind of thing?
There definitely is, because we saw over the last years that this topic in general, like STEM, right, science, technology, engineering, and math, actually got more bandwidth online, in media, all across the board. So we see an increase in interest and attention. But the question
look
is,
at this on the screen there. This shows a lot of interest, right?
Yeah, this is actually from the first robotics challenge, one of the finals that was recently, and a lot of kids are interested in it. It touches over 200,000 children across the globe.
Back up. How many?
Over 200,000.
200,000?
Across different age ranges. But the question is if that still is enough, right?
Okay.
There's more that needs to be done in this area.
And so what are some of the things that engineering can do?
So there's obviously there's a lot of things that where engineers are involved, but there's the National Academy of Engineers just recently put out some what they call the Grand Engineering Challenges. And they identified 14 different areas, and they touch our everyday life.
Okay.
It's about clean water, it's about energy, structures, medicine, cyberspace, right? We touch the things every day, and engineers are responsible to make those things work and available in the future.
So these are some of those items, the 14 items that we're seeing on the screen, and they are put out by whom again?
It's the National Academy of Engineers.
Okay.
And they were basically asking very clever people around the globe, and they were basically, this feedback was collected, and they came up with those grand challenges.
What are some of the top things on that list that if we can have it back up for a moment, what are some of the top things that you think people should zero in on?
I think some things, especially in the developed world, that we take for granted: access to clean water, access constantly to clean energy, right? Those kind of things, we take it for granted, but it's definitely not for granted for everybody around the world, and this is what engineers have to take on for the future.
And so engineers can play a role in those things.
Absolutely. Excellent. They have to.
Thank you, team. And so the reason I wanted you here is that National Instruments has made a significant impact on two people that I have known for a long time. One gentleman, Michael McNary, who I worked with him when I was a senior at University of Southern California. He was in the 7th grade. Now he's a physicist working in Oklahoma on fracking. And I taught him how to use a microscope. And he told me that the reason he had gotten advances in his career is because of your product, LabVIEW. It made a difference. And I asked another colleague of mine who has been an engineer at IBM, retired now, for about 30 years, and he said LabVIEW also made a significant impact on his life.
Yeah, I'm glad to hear that. And we get stories pretty much all day, especially in my role. I can work with students, with professors, so we quite often get this feedback that there's like a certain trigger that sparked this interest in engineering, right? And I want to actually spend a minute on LabVIEW as well, because it is a great tool which is very intuitive the way we actually use it in engineering space. But leading to that is the question, right? How do I get actually people interested in engineering at all, right? Whose responsibility is it to make engineering fun again?
Okay.
And if you look around, especially again, if you look at the media, people want to be NBA, NFL stars, right? We just had the Super Bowl. People want to be Hollywood stars.
Right.
If I go back maybe 30, 40 years, people wanted to be connected to a space program, flying to the moon.
Right.
Engineers were the heroes of that time. And I think it's time that everybody starts helping to bring that back on in the family,
Right.
as well as in schools and then in college. And industry companies like National Instruments, our responsibility is to deliver tools, and you just mentioned LabVIEW, that's definitely one of them,
Right.
to help make it feasible to take on those challenges.
Now, let me ask a question. Are girls interested in this as well?
I can answer that question with yes, if the challenge, the question is raised appropriately, right? If we talk about children and robotics,
Right.
if I take a group of boys and girls and I put out a question in regards to robotic, build a car that can drive along this line autonomously, the boys will immediately jump on that topic. Right. The girls maybe stand back a little and ask them why. So to get girls interested in engineering, it has to have a social contact, it has to have a meaning behind it. So why do I do this?
Right.
And then they're sometimes even outsmart the boys.
Well, that's good. In that picture we saw, they were making was it a crocodile or something?
Yeah, so this is again, right, we try to get even earlier interest in those kind of topics. So when do kids decide what they want to be later, right? It's probably when they're 10, 12, 13, 14 years old. So if we can spark an interest in engineering, bring this curiosity back in there, which they have as kids, right? Every kid is building something. And what you saw here is a product from Lego. It's called We Do, and it actually focus on kids very early on, age 6 and 7, and even younger if the support maybe from the parents is there. And they built this little, in that case, a Lego crocodile that interacts with you by, if you put your hand closer, it closes his mouth through a sensor.
Right.
And kids start to understand how sensors and maybe motors can work together and do something which they have in their mind.
Yeah, and Caltech is using Legos and a project I mentioned off camera in terms of using laser beams to try to speed up the breaking apart of water. And having teams all over the world work. At Pasadena City College, we had for a time a small team contributing, trying to learn a little bit about that. So Lego is really heavily involved with a lot of stuff.
Absolutely, and National Instruments actually in this domain actually a global partner of Lego. So lots of things that work on a bigger scale also work in a smaller scale, right? And it's again a question, what are the right tools that especially already children or young students can actually take on those questions. And National Instruments partnered with Lego, and we deliver the software that kids are actually using to program those embedded systems. If you would look into it in detail, it's very complex systems, but we bring a very high level of abstraction in there so that children can use it in a playful manner.
Right. And so you have some examples of some of the interfaces that you use to help people see the practical and the, I guess, even artistic aspects of engineering and some of your GUI stuff, you know, that kind of stuff, that the images that you showed us off camera.
Yeah, absolutely, absolutely. So I think it's important when we talk about tools, right? What we provide as National Instruments, we're a tool provider for engineers, scientists, and researchers. And I think a tool works best when you can start very early on learning the basic concepts, and then you start advancing, sometimes through your age because you learn more, so you want to apply more, or by the challenges that are brought up to you, right? You need to add something to that tool, but you don't want to dump and disregard everything you learned so far, because it's a time and sometimes even a money investment, right?
Right.
So
let me ask a question. If people get spark an interest in what we're talking about, how would they get in contact with you to learn more?
So the best way is, obviously, we're a global operating company. There's, in lots of major countries, we have over 40 direct branches in those countries. But basically, the easiest today is probably the web. So you can go to our webpage, ni.com. There's a special academic program, very prominent. There's a button right on the top. Or you just use Google, right? And you will find schools and universities in your neighborhood that apply our tools in mechanical engineering for building maybe a rocket,
right,
or maybe in electrical engineering to look into the challenges of smart grid energy
right,
harvesting. And on our webpage as well, you find a lot of direct contacts.
right.
And we have colleagues like myself who work
Okay.
with industry customers and with educational customers.
And so that's ni.com.
That's correct. And
For National Instruments, okay,
that's
NI.
correct, yeah.
So if you wanted to motivate a child or a person, do you have an image you want to share us to show us how this more sophisticated growth, because you not only work with young people, but you have a philosophy and methodology that you can follow them as they become more and more sophisticated,
Yeah.
right?
I think the most important thing to understand why our tools are very widely used and from early on is that our tools are graphical.
Okay.
So basically history, if you look back, like if people used computer to do things for them, it used to be a text-based approach. So someone had really to learn a programming language which was text-based, with commas and full stop and semicolon, all those kinds of nifty things that can make it complicated, right? And our approach is to have a very intuitive approach of telling the computer, telling a machine what you want it to do.
Right.
And also, if I take the example of a kid understands symbols, graphical symbols, way earlier than they start reading, writing, right? So it's very intuitive and natural to us. And we use this graphical approach because also in the engineering world, if a group of engineers comes together to define a problem, a challenge, they do a flow chart first, right? They say, this is where we start, this is what we need to figure out. If we do it good, we go down this path. If not, we go down this path, and we reiterate.
Right.
And this is how our tool actually looks like. It's graphical blocks that people can combine to do something very, very specific.
Right.
But there are people who like to work in a very specific way with certain challenges.
Right.
So our challenge as a company is to basically provide a core tool like LabVIEW and then kind of have offspring, certain flavors, so that still the user can decide how to work with it. Like we have kids being 7, 8 years old, and we have engineers who solve very, very big engineering challenges, and they might have to have a very specific approach. And even, again, something which is textual math.
Right.
So we try to have a very open architecture that those people can just pick from whatever way they want to come into our platform. And then I think we're another very, very big differentiators for National Instruments. We allow very complex hardware underneath it to be used without having to have always the domain expertise. So
okay, interesting. Do we have? I think we have a graphic to show an example where you have an image of the a graphic interface with a textual interface and show flow charts and stuff.
Yeah, if you can pull that one up. So what you mentioned here is basically in that image, what the viewers can actually see is a graphical code which looks like graphical blocks that are kind of stitched together basically. You see graphical blocks here in that image and lines that flow between the blocks. We call that data flow. And this is basically the base of our program.
Right.
Information travels on those wires from one logical block to the next, and all blocks represent a certain functionality.
Right.
But then again, what I mentioned before, some people probably want to represent a certain mathematical function in a different way.
Right.
So we allow them to do that as well. We call it the math script node. So they can type in textual math functions the way they maybe use it from a blackboard when the teacher was showing it to them. And then others don't even want to touch the programming side, right? But they need to be able to interact with maybe a very complex system. So also very powerful with LabVIEW is to design very quickly a very powerful GUI so that the user who might not be a domain expert, just a technician, but he has to operate a big machinery, just gets sliders and buttons with those informations that are suitable to him to make an educated decision on the process.
Yeah, and that's what you see on the screen.
Yeah.
The one on the lower left is what we're talking about GUI,
Yeah.
which is was a graphic interface or something.
And basically, when it comes to pictures and you want to show a lot of things, sometimes it looks messy. So please picture that when a program is running, the GUI would ideally take up the whole space so that the information that is provided can be seen, right? And what we see here in the rest of the picture with the white background, this is what the developer would do during the program development. But once the program is running, you have a very nice big GUI, very clear with the information.
And plus that one on the right also can tell you if there's a mistake and where it's going to be at.
Absolutely. During program development, you want to make sure that you understand the flow of your program. Sometimes you want to branch off things to run in parallel to speed up certain algorithms, maybe, or certain decision-making processes. And then again, what you also see in the top half, there's a process which runs in the graphical code, and then below that one, the viewer can actually see something which is represented again in the classical text-based version. And
yeah, from personal experience, I would say that this is a very powerful thing, and to have a team of people that you can call on is extremely beneficial. And so one of the things we have to show is what we have is an example of my own sample practice. MyDAC it was called, and so tell us a little bit about what this is. So
I'm glad you mentioned the MyDAC. So basically, what this is we call it a student lab.
Okay.
Right. What we also saw over the last years, we have social media coming up. We have lots of pages which a lot of information about engineering concepts, where people can just go online and learn something. I think the engineering part, really the skill comes in when someone can tell the difference between the theory, the perfect world, and what happens in real world, right? There's certain things that just make that signal maybe look a little bit different.
Right.
And engineering kicks in when you are able to tell the difference, say, this is still okay because this is expected. So that leaves the challenge for, say, a university lab. How do you do that with 200 students in a certain course, right? Lab space is very limited.
Right.
It is very expensive. And usually what we saw in the past is that every student gets a certain time slice on that equipment and rather goes through a cooking recipe.
Right,
and
exactly
steps
right.
out of the lab and almost forgot everything already, right? That at least happened with me in the past.
Right.
So what we were actually working on, and we have actually very, very strong partners. In this case, for this particular hardware, we worked with Texas Instruments, who provided a lot of the components inside this MyDAC unit. So basically, we tried to take a whole typical instrumentation lab, put it into this little box, which is USB powered, so a student can just plug it into his laptop, and give him the possibility, or her, to do all those engineering work in the dorm, at home, as a project and homework assignment, and then come back and regroup with the instructor and talk about the findings.
Right. Yeah. Well, that's good, because I see on the image there, we see them using a MyDAC and working as a team in the laptop. And those things are really helpful to know that you can have hands-on, and you can do it at home or out in the park, wherever you want to actually learn the material.
Absolutely, and I think the important thing is also that it has to be still industry rated. It needs to be maybe a scaled down version, because obviously you also want to bring down costs, so it can be made available to students, but it can't be something special that it's only for teaching, right? You want to make sure they learn something they can later use in their professional career and make an impact.
That's right. So once again, if you want more information about learning more about engineering in general, a good place to start would be a National Instruments website, ni.com. Be prepared. There's a lot of stuff there, a lot of videos, a lot of testimonials, sample things. You can easily get overwhelmed, but if you have a starting point and just take it slow and realize this is designed to be with you for the rest of your life, and you can grow with it and not try to eat the whole elephant at one time, but just take a little bit at a time, it'll be less frustrating for you. And you also know there are people out there like Ingo around the world who want to help you, and they're really motivated. And everyone I've talked to, and no matter what level they are in tech and National Instruments, have been very helpful and supportive of all the different kinds of things to teach me a little bit more about it. What else would you like to have the audience do, since we have about 5 minutes left? What kind of action you want them to take?
So I think, especially what you just mentioned, right? Start right now where you have an immediate idea, problem, use. It's a little bit like with our tools, it's like learning to ride a bike. You start with a small bike, it might have the supported wheels on the side. At one point you take them off, you feel you can actually go by yourself, and then at one point you maybe advance to a street bike, to a mountain bike, and this is actually the same. So look around, and I think it's important when it comes to engineering, especially to get started, just have a crazy idea.
Right.
And especially, you mentioned ni.com, and if you Google for the MyDeck product, you will see actually what students are doing with it. And it's all kind of fun ideas,
Right.
but it makes engineering fun. And without knowing, you learn actually tremendous skills, which later can be applied to real world problems. So I can just encourage people, and especially also, I think there's a big discussion if students get the right things in university, in colleges. I think no parent should take him or herself out of this discussion. And
I agree
always
wholeheartedly.
encourage their children to look into this possibility, career possibility as well, and not just go down this fixed path that a lot of people went down before. So start somewhere where it's fun, because if something is fun, it actually normally sticks, and
Right.
you want to keep doing it.
Yeah, fun is a good thing. And as you were talking about starting earlier, I am interested in working with young boys who are like 5th grade, because when I was in the 5th grade, I had an interest in, you mentioned the space program. I wanted to be an astronaut in the 5th grade. And then one of the astronauts switched to become an aquanaut. And then I switched and had an interest in the marine biology, and now I'm teaching marine biology and on this board with the USC and regarding the deep ocean exploration. And so I wholeheartedly encourage the parents. The children are never too young to start.
No.
And you as a parent are never too old to help them and be with them and be a part of this learning process. Even for yourself, you might want to get out there and just learn this stuff, even just for yourself as an adult. This is so versatile that you can use it for yourself, your children can use it for themselves, you can work as a team, and you can even have it at a family reunion. Think about this. At a family reunion, you have an engineering contest, not only baking cookies or frying things or having barbecues. You have an engineering contest at a family get-together. It's a marvelous kind of possibilities. Because as Ingo mentioned, water is a big thing. And somebody has to help us deal with the water issue. In California, the big discussion is water coming down to Southern California, the concern about in Sacramento in terms of the dams and then the levees and all of this kind of stuff. Water is a big deal, and engineers are going to be some of the people solving those problems. Do we have another image? I think do we have all of them shown?
I think we went through all of them. It's just basically it's just a trigger for ideas, right? People really have to go out there, look, especially in their environment. Also, from the first Lego League, which addresses the very young children, there's always this robotics challenge which they build, but there's always a project. So they have to look in their environment and can see how they can maybe do a positive impact to their everyday lives through.
Oh, look at this. This is one of the things you were talking about, little video showing the robots moving around.
Yeah, so this is our founder, this is Dr. James Truchard, and we actually partner with First to deliver industry-rated, very powerful tools so that kids can focus on bringing their ideas to life and build robots that in a playful way take on certain challenges, which do have a real-world aspect behind it, because the concepts of building these fun robots are totally the same of building, for instance, the Mars rover that in the end goes out into outer space, right? It's the same.
Right, and I think that in talking about exploration, a big area of exploration is going to be the seafloor here on our planet. We know more about the surface of Mars than we do about what's in the deep ocean here.
And it's interesting that you mentioned both, because we do have customers who do measurements about a mile underneath the ocean surface on vibration measurements on pipelines.
Right.
We had tools running on the Mars rover, and what we actually say, if we're on the Mars and at the bottom of the ocean, probably somewhere in between, we'll find something that you are challenged with, and we definitely can help there.
And this is a program that's designed to show you that engineering is exciting. And even if you have not an engineering background, you have a question, a practical question that you want to solve some technological issue. And this could be a way that you can try to solve a problem. Maybe if you're a potential entrepreneur that you don't even know you're an entrepreneur, you may come up with a solution to a problem by just learning a little bit about this website at ni.com. And I think you'll find that is something that's worthwhile to explore. And so you can get involved with that in a very special way. You can contact me, or you can get in contact with the station, and we can get you some more information about these kind of things. Since we have about 2 or 3 minutes left, what would be the message you want us to go away with?
So basically, I can just repeat it. Also, the title we had for this show, right? It's do engineering, go out there, help to improve everyday life by taking on science, technology, engineering, and math. Like, don't step away from it, right? We have to get more people interested in engineering because these are really the people who will influence how we're actually going to live in future. And I can just again mention, get involved and look at things that people do with Lego and their Lego robots. It's a very good starting point, and you will see, especially if I talk to parents and educators, you will see how your children, how your students actually, they spend more time on this than you would actually expect.
Right. And also some of the things where parents might say, well, then will children be interested? If we can have that first video with all of that in the stadium, there with all those young people in this big stadium. But also keep in mind, if you like the Black Eyed Peas, will.i.am is involved with this particular type of program. And so he's done a special on that. If you go search will.i.am and first, you will find out that not only are the geeks involved, but the people involved with the entertainment field. And if you watch the Black Eyed Peas, they are always involved with technology and stuff like that. So this is a future for you if you're musically inclined, if you're an artist, if you're a poet. These kind of things can be of interest to you because someone has to share and discuss these kind of things. That's why we are so happy that our guest came here today. Ingo, hopefully you can come back again and join us, because I think I want to follow up with this to see what we can do in the future. Maybe have some young people who are using LabVIEW in this area to come to the studio and we can interview them. And I think seeing other young people is really good. Again, this is Dr. Joe Connor, the Connor Bubble, and we've had a fantastic program about doing engineering, and hopefully you get out there and do some engineering yourself. All right, thank you very much.
Thanks for having me.
This is so cool.
Yeah, I love it.
I just love the